Hi, welcome to my YouTube channel of learning chemistry. This is where we learn chemistry. Today we are going to talk about symbols of elements and their symbols. But before then, have you subscribed? Please do subscribe. Okay, press that red button there and then hit the notification bell near it so that anytime I post new content you will receive it. And for my returning subscribers, you know I am always grateful. I am grateful from my heart. Please keep returning. So let's get started.
Over the horizon, over the horizon.
Welcome back. So like I said, today we are going to talk about symbols of elements. Now there's this guy called Berzelius. In fact, I love the whites. And their dedication, because of their dedication. You know, these are the people we call the real scientists, because they go to any length in order to discover things, in order to find out why this is as it is, in order to prove something. They don't cut corners. No. They go to all lengths, any length, in order to discover something. So this Berzelius is one guy. I'm sure he has been wondering, you know, seeing so many things and not knowing what are these things? What are these things? And he now decided to research, and then he came up with what we are going to study today: symbols of elements. He suggested a simple system of representing elements with symbols. You know, so just when you want to say talk about hydrogen, so just putting the H there, you know, in a short form, especially if you're in a hurry, you write hydrogen, you know, so long. So this guy discovered a simple system of representing them with symbols. That was in 1814. How many centuries ago? 1814. So it's not today that chemistry started, you know. So the first letter of the name, and how he did it is each element, he used the first letter as the symbol. For example, hydrogen, he now used H. Nitrogen, he used N. Oxygen, he used O, and then so on. Now he now found out that, you know, so there are sometimes more than one element can have the same symbol, starting the same alphabet, starting its name. You know, like we have hydrogen, we have helium. Both of them have HH. So in order to avoid confusion, he now decided that after when you have chosen and already chosen an alphabet and a similar alphabet, then the next one following it you now add the next letter after the next letter in the name. For example, helium is spelled Helium. It now became He in order to differentiate it from hydrogen. So H for hydrogen, He for helium, you know. And then calcium, Ca, because we have already chosen carbon, which is C. So Ca for calcium, you know. Chlorine, Cl, to differentiate it. Now he still continued, you know, to keep on differentiating. Some elements were now their Latin names. The first two letters of their Latin names had to be used in order to still differentiate. For example, sodium we now use Na, which is derived from the Latin word natrium, Natrium, natrium. So sodium, the symbol for it is Na because it's derived from natrium. Because you cannot keep on using the same symbol and then adding more letters to it. So to make it now becomes a word and no more a symbol. So he had to now think of another way to also make it to still remain a symbol. So he had to use their Latin names. So iron, IRON, the symbol is Fe, which is derived from the Latin word ferrum. Silver, SILVER, the symbol for silver is Ag, which is derived from argentum. Tin, TIN, the symbol for TIN is SN. The symbol for tin is SN, derived from the Latin word sternum. Gold, the symbol for gold is AU, derived from the word aurum, AURUM, aurum. And copper, the symbol for copper is Cu, derived from the Latin word cuprum. So these are the elements whose symbols were derived from the Latin words, and sodium, iron, silver, gold, tin, copper. Now, the first 20 elements, I will list them in the description box, and you also see them on the board. They are, well, during my own time, we derive the kind of what they call it, and there's something they call it. We used it to remember the elements, and the first 20 elements of the periodic table, and we used to sing it like this: hello Helen, listen baby, before coming, never offend Flora Nelson. Now Maggie allow Silas pass so close after killing Carol. So hello is for H, and Helen for helium, listen for lithium, and baby for beryllium, before for boron, coming for carbon, just like that. And the thing helped us and to say these first 20 elements. So that's it on the board. The first 20 elements and their symbols as discovered by Berzelius, and these are the atomic numbers. Each element has an atomic number and a symbol. Now these are the atomic numbers, these are the elements, and these are the symbols. So atomic number of hydrogen is 1 and the symbol is H. For helium, atomic number is 2, the symbol is He. For lithium, atomic number is 3, symbol Li. For beryllium, atomic number is 4, symbol is Be. For boron, atomic number is 5, symbol is B. For carbon, atomic number is 6, symbol is C. For nitrogen, atomic number is 7, nitrogen is N. For oxygen, atomic number is 8 and symbol is O. For fluorine, atomic number is 9 and the symbol is F. And for neon, atomic number is 10 and the symbol is Ne. So for the acronym, we used hello Helen, listen baby, before coming, never offend Flora Nelson. So as you're saying it, automatically you are writing down everything, without having to even start thinking. So we move on to the continuation, and 11 atomic. So for sodium, atomic number is 11 and symbol Na, natrium. For magnesium, atomic number is 12 and the symbol Mg. For aluminium, atomic number is 13, symbol Al. For silicon, atomic number is 14, symbol Si. For phosphorus, 15, P. Sulfur, 16, S. Chlorine, 17, Cl. Argon, 18, Ar. Potassium, 19, K. and calcium 20 Ca. So when we there, na Maggie, the acronym, na Maggie allows Silas pass so close after kissing Carol. So that has been in my head, and I always use it, apply it anytime I'm dealing with atomic elements and their symbols. So that's it. Okay, it will also be in the description box for you to be able to master it better. Okay, so we now move to formulae of elements and compounds. The formulae, how do we derive the formulae of elements and the compounds? Now, a molecule, we've already discussed molecule, so we all know what molecule is. If you don't know what it is, please go back to my channels, to my other videos. You know, I think the last video I talked about molecules and atoms. So a molecule is represented, a molecule of a substance. A substance is represented by the symbols of its component elements. The molecule of a substance is represented by the symbols of its component element, and such symbols are called chemical formula. That is what we mean by chemical formula of a substance, when you represent that substance by its symbols. For example, hydrogen has H2, so it's a molecule. It has 2 atoms, so it's a molecule. You know, anything that any element that has more than 1 atom has automatically become a molecule. You know, so hydrogen is represented by H2. 2 is the subscript there, you know, to show you that it contains 2 atoms of hydrogen. It's a molecule. Sodium chloride, the chemical formula is NaCl, as it is on the script. NaCl, that's a molecule, and that NaCl is its chemical formula. Now, if an element is used as a molecule, a number representing its atomicity is written as a subscript, just like I explained now. When the element is used as a molecule, a number written as its atomicity. Atomicity means the number of atoms that element contains, that is contained in that element. So if it is used as a molecule, a number representing its atomicity is written as a subscript after the symbol of that element. For example, I already explained hydrogen, which is called diatomic because it contains 2 atoms of hydrogen. We also have triatomic, like ozone contains 3 atoms of oxygen, you know, so that's a triatomic. Ozone is triatomic, and then that 3 is written as a subscript after O. Now, a molecule of a compound contains whole numbers of atoms of the component elements. It contains whole numbers of atoms of the component elements, and its molecular formula is written as, this is the rule how to write the molecular formula. What we discussed earlier is a molecule of a substance. Now we are discussing a molecule of a compound. And a compound contains more than one, that's more than the different types of elements. They contain different types of elements. For example, sodium triisocarbonate 4, so it contains sodium, carbon, and oxygen. That's a compound. Calcium triisocarbonate 4 contains calcium, carbon, and oxygen. That's a compound. So they contain different elements with different number, each element with a different number of atoms. Now, they are written as follows. The molecular formula is written as follows. The symbols of all the component elements are written close together as a group. The symbols are written close together as a group, like on the board now, as you're seeing on the screen now. Calcium triisocarbonate 4, the symbols are written together as a group. That's calcium, followed closely by C, carbon, then followed closely by oxygen, which has 3 atoms written as the subscript. That means that's how they are written together as close together as a group. Then the number of atoms of each component element is written as a subscript after the symbol of that element. Yes, just like you are seeing it now. Now we have some, we have di, and we have potassium heptaoxodichromate, potassium heptaoxodichromate 6. Okay, it's written as K subscript 2 on the board. Sorry, on the screen. K subscript 2, meaning it has 2 atoms of potassium. Cr, that's chromium, subscript 2, 2 atoms of chromium, and then O7, 7 atoms of oxygen. So potassium heptaoxodichromate 6. Now, the molecular formula of calcium triiodocarbonate 4 is CaC. I've already explained that to you. Now from there we move to radicals. We have, there are things. There are also some molecules or compounds or group of atoms known as radicals. Radicals, not the radicals radical human beings we see. That's the English interpretation of radicals. But then in chemistry, we have a chemistry interpretation of radical. Yeah, and this group of atoms that you're seeing now on the screen, we have trioxonitrate 5. That is minus sign. They are all ions because of the charges that they contain. Either minus, most of them are always minus anyway. Minus N, nitrogen O with 3 atoms. That's nitrate, trioxonitrate 5. Then we have hydroxide, minus OH, oxygen and then hydrogen. We have trioxocarbonate 5, that is minus C, carbon, and 3 atoms of oxygen. And then we have ammonium, minus nitrogen, and then 4 atoms of hydrogen. These are called radicals, and each is treated as a single unit in a molecular formula. Yes, they are treated as a single unit in a molecular formula. Like if you're writing, if you're using, I'll explain to you what they mean as a single unit. Like for example, you're using OH, that's hydroxide. Now in a molecular formula, we have something like sodium hydroxide. That is Na, sodium on its own, and then OH. So that OH now is a single unit on its own. It's treated as a single unit on its own. Sodium OH. Then we have CO3. We have something sodium triiodocarbonate 4. It's meant to contain Na, sodium, 2 atoms of sodium, and then CO3. 2 atoms of sodium and then CO3. It is treated as a single unit. It's not split. Single unit is on its own, independently on its own. Now, if more than 1 unit of a radical is present in a molecule, then the formula will now be written by enclosing that radical in a parenthesis and then writing the number of its number as a subscript. For example, calcium hydroxide. As you're looking at the screen, calcium hydroxide, you can see OH is written in parentheses, and then that subscript 2 is written after it to show that oxygen contains 2 atoms and hydrogen contains 2 atoms. That's also an example of it being written as a single unit. Instead of writing Ca, O2, H2. That's funny. Very funny. So you now write calcium hydroxide with a parenthesis showing that we have 2 atoms of hydroxide. So the subscript outside the parenthesis applies to every symbol. So that too applies to every symbol within it, so that it is understood that both oxygen and hydrogen and they both contain 2 atoms. So with this, we've come to the end of this particular lesson. I hope you enjoyed it. This is one of my favorite topics in chemistry. I hope you enjoyed it. If you did, give me a thumbs up, and don't forget to comment if you feel you need to comment on something. If you don't feel like commenting, it's not a must. The important thing is for you to learn it. you know. Now also read the description box. Always go to my description box, because many things are written in that, many information are written in that description box. So please, once again, don't forget to subscribe. Yeah, I mean, it's not just chemistry channel I do here. I also talk of real life stories, real life issues. You can learn either way. Okay, you can learn either way. Subscribe, hit the notification bell so you don't miss any video from me. So till then, thanks once again for watching, and bye.